Okay, amine salts and heterocyclic amines. Now complete the following reactions that react each product with sodium hydroxide. So we'll complete the reaction. They just took up too much room, so I couldn't put below. So here we are. So first thing is we're going to do this reaction out, and then the product we're going to react with sodium hydroxide. And we're not going to leave it as a mystery. What we're going to do is we're going to create an ammonium salt, substituted ammonium ion, and then we're going to use the base to get back to the original amine. So this thing would look like, we add the H+. The water in the last lecture acted as an acid. Water can act as an acid or a base, but here is a definite acid. It adds the, let me get that over here, H+, and then we have the Cl-. Now that then, once we're done with making this salt, then we react it with sodium hydroxide and we can get back to the original amine. But there's other things. The sodium goes off with the chlorine to create salt, and then the H+ goes off with the OH- to create water. So the main thing that we're doing here is, this is very common, to be able to take a molecule, change it into something else, and then change it back. And in biochemistry that happens all the time. That's why we have so many cycles that we talk about in biochemistry, because we're allowed to go back and forth with different types of functional groups. Okay, so if you're given this, just know the H+ goes onto the nitrogen, and we create a salt. So just draw it out. Now put NH3, or add an H to it. If it has another, like a methyl group out here, then we just add, have that methyl group in one hydrogen, and then we just add one more. But add one more add an H+ to it, and then we have our Cl-. You can put it right there to indicate that this is all one ionic compound. And then take this thing that we just created, and add sodium hydroxide to it. The thing is, first, you know that even if you kind of get lost at this point, so you know we're trying to get back to the original molecule. So you have that, so just draw the original molecule. Then, sodium and chlorine. That should strike you as something that would go together. And then you have H+ and OH-, and we create a water molecule. Surprise, surprise. Most of these seem like that's what we're doing. We create water molecules, or we use water. So that shouldn't be something that should be, knock you out of your chair. Okay, now react ammonia with 1 chloropropane to create the 3 types of amines and quaternary ammonium salt. So this is given in your book in these steps. So we have ammonia, and we can draw it like this. And then we have, it's propane, so 1, 2, 3. And what we do is we create, we're just going to write base up here. So what that's going to do is it's going to react. All we're going to do is take out a H+ and put on the propyl group. And that's all I want you to know there. Now what happens is the H+ goes with the Cl-, reacts with a base and gets neutralized. So we end up with sodium chloride and water. But all I want you to do is be able to take this and create the primary amine, and then take the primary amine and just continue down the line. Add another. So, well, it's not balanced. So we've come across those reactions before where it's not balanced. We're only interested in the main product. So we have nitrogen. We have 1, 2, 3, and then 1, 2, 3, and then 1 hydrogen left. Then take that thing. It's getting to be, so 1, 2, 3, 1, 2, 3, and add another propyl group to it. The base takes care of, allows this reaction to go to completion. If we didn't have the base, it would just create a salt. but the base neutralizes it and turns it back into an amine. So we have this guy. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and that's it at that point. But we can go one step further with this. 1, 2, 3, 1, 2, 3, plus. And that's what's special about the amines, that we can go one step further and create 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It looks like a spider. Plus NCl minus. So you just keep adding on. It looks, oh wow, there's so much going on. Not really. It's just we keep adding groups to it, take away the hydrogen, take away the hydrogens, and then we can go one further. A nitrogen is allowed to do that, to create that substituted ammonium ion. And then draw an example of a heterocyclic amine. It's any ring system that contains one or more nitrogens that are part of the ring. And that's it. So here's one. And there's unlimited numbers of them.